Over 16 million private homes in Germany need to stop using heating oil and gas as quickly as possible. Yet there's a limited choice of renewable fuels, like wood pellets, available. And what many see as the future game changer, green hydrogen, is exorbitantly expensive and unreliable due to the limited ability of solar panels to generate enough heat in Germany in the winter months. Hundreds of thousands of homeowners will have to install heat pumps in the near future in order to ensure that the supply of heat in Germany is climate neutral. But many of the homes are more than 30 years old. They require more heat than modern houses, yet their heating systems tend not to be designed to run a heat pump. Like the Rommel family in southwest Germany. They have an oil tank in their basement, technology from the 1980s. I want to have a steady supply of heat, but I also want to stop using oil and gas. And considering that I'll be generating a lot of electricity myself in the future, a heat pump seems to be the logical next step. It's a spring day, and the thermal heat pump is being delivered. Heat pumps use electricity. If the electricity is produced climate neutrally, the entire house can be supplied with heat without generating CO2. This air-to-water heat pump will provide warmth for Walter Rommel and his family. The outdoor unit absorbs the environmental heat of the immediate surroundings. Outside air is drawn in by the unit. The air then transfers its warmth to a special refrigerant via a heat exchanger. This refrigerant boils or evaporates even at temperatures below minus 20 degrees Celsius. The gas created by this process then flows into the heat pump inside the house. Once it reaches the heat pump, the gas is compressed and heated to a high temperature. Electricity is required for this. The hot gas then transfers its heat to the heating water in the house via another heat exchanger. In the process, it condenses and flows through a throttle valve back to the outside for evaporation. Electrical energy is used to raise the ambient heat that surrounds us to an even higher heating level. The heating pump is particularly efficient when it generates a large amount of heat with as little electrical energy as possible. To do this, the heating temperature, that is, the temperature of the water inside the heating system, must be as low as possible, and that requires heating surfaces to be as large as possible. About half a year before the heat pumps are installed, a plumber will come to measure the size of the radiators. The rule of thumb is, even at low outdoor temperatures, the heating temperature must not exceed 55 degrees Celsius. The specialist analyzes how much heat a room needs in winter, and whether the radiator surface is large enough for this. Floor, wall, or ceiling heaters with a large surface area are ideal. The surface heater has the advantage that I can work with even lower temperatures. I can even cool with surface heating. I can't do that with a radiator. This has a lot of advantages, but installing it is a big deal in a house that is being lived in. If the heating capacity of the radiators isn't sufficient, and homeowners wish to avoid expensive installation of underfloor heating, so-called low-temperature radiators are an alternative. These are radiators through which the heating water flows. Above them is a row of small fans that suck air through the fins. This airflow increases the heat exchange compared to the normal radiator. As a result, the overall heating temperature can be lowered. In the case of the Rommels, the calculations show that the old radiators in the family house are large enough. When the radiators were installed 40 years ago, they were already thinking in large dimensions. We won't need to make any changes at all to the radiators. They're big enough for the heat pump and they should be able to work efficiently here. The old radiators can stay. This is often the case in many existing buildings. The old oil heating system, on the other hand, will have to go. Before that's done, though, it can still provide important information. This machine can't record any temperatures, so you'll have to keep a journal. What that means is, in the winter, you write down the outside temperature on a piece of paper, and do the same with the thermometer on the heater. This will give you the flow temperature from inside to outside. I'll need that information from you when the winter is over, and I can use it to calibrate the new heat pump system. The concept behind it is simple. In the last winter of its operation, the homeowner lowers the overall temperature of the old heating system. By doing this, they find out the lowest possible temperature, which will still produce comfortable heat in the house. Once the lowest possible temperature for heating is established, the old heating system is then removed at the end of the heating period. Systems using oil often drive the heating water to over 70 degrees Celsius, even though this is not necessary. With heat pumps, however, the lower the temperature, the higher the efficiency, even if it's just a few degrees. In the case of the Rommel family's house, the analysis showed that sufficient heat can be generated in the rooms even with a maximum heating temperature of just 52 degrees. The old oil heating system has been removed and the new heat pump is being installed. Technically, the new system should actually be able to provide more heat than the homeowner wants. If you install a heat pump in a building with existing radiators, then the heat pump must be able to heat up to at least 60 degrees Celsius. That's information you can easily find on the spec sheet. We won't want to heat the water that high. It's most efficient if we only operate the system at 50 or 55 degrees Celsius. That means the system needs to do more than is needed for everyday use in order to function with maximum efficiency. That would be perfect, ideal, exactly that. In order to keep the electricity costs from becoming too high, the heat pump should generate at least 3 kilowatt hours of heat from 1 kilowatt hour of electricity. The Rommels have an older home, and even there the heat pump generates 3.5 kilowatt hours of heat from 1 kilowatt hour of electrical energy. In addition to the heat pump and the outdoor unit, the entire system also has a buffer tank. The tank can maintain the heat supply for a few hours when the heat pump is not running. And the volume of storage can be increased with a simple trick. Specially fitted plastic containers are placed into the buffer tanks. The containers are filled with particular kinds of salts or oils. These substances change their aggregate state from solid to liquid as the temperature increases, for example, at 50 degrees Celsius. During this change of the aggregate state, the material absorbs a much greater amount of heat energy than the same amount of water would absorb. Which means that a 1,000-liter storage tank suddenly has the heat storage capacity of around 2,500 liters. The good thing is, if you have your own solar power system, or if you have the possibility to get cheaper electricity from your provider, then you could say, okay, here at this time of day, when electricity costs less, I'll charge my buffer storage during the day, for example, with the photovoltaic system. And then the heat pump can store so much that it might turn itself off the next night, or maybe even 2 or 3 nights. With this method, solar power generated during the day can be stored as heat for the following night or the next cloudy and cold day. Before the heat pump starts operation, the old radiators are flushed clean. During this process, the heating water flows through a filter. This ensures both that no deposits clog the valves and that a defined volume of water flows through the radiators later during operation. Ultimately, the operation of the entire system can continue to be optimized making it possible to lower the temperature even further. Before the initial startup, a hydraulic calibration is done. This adjusts the flow rate of each radiator and further increases the efficiency of the entire system. A few days after the heating system is put into operation, the heating specialist shows the homeowner how the app works. The app is used to adjust the heating temperature to the needs of the family during the next winter. The temperature is set as low as possible. In this way, the homeowner can further optimize the operation of the entire system and use even less electricity. Ideally, continued renovation would reduce the amount of energy required to heat the house even further. The Rommel family's house is just one example of how heat pumps can generate climate-neutral heat in older homes. This is how green energy can be used incredibly efficiently. Heating completely without oil and gas.